students, myself Mahima Laharia from Vijayanagar College Hospital. Welcome to my YouTube channel Pacific Chemistry Classes. Students, today's topic is our spectroscopy and I hope this topic is very familiar with all the students. The name आपने सुना ही है, लेकिन इस टॉपिक को समझने के लिए पहले इसमें कुछ बेसिक कंसेप्ट हैं. If the basic concept are clear, so you can study any type of spectroscopy, as there we have heard the names of many spectroscopy such as infrared spectroscopy, ultraviolet, microwave, NMR spectroscopy, ESR spectroscopy, NQR, mass spectroscopy. So to understand the different types of spectroscopy, we should know the basic concept which are needed to understand the concept of spectroscopy. So this video is mainly I made to explain the basic concept of spectroscopy. Now we can say that the spectroscopy technique हमारी क्यों हम स्टडी करते हैं, तो हम सिंपल वर्ड्स में बोल सकते हैं किसी भी मॉलिक्यूल का जो स्ट्रक्चर होता है या उसमें जो फंक्शनल रूप प्रेजेंट होते हैं, उसका जो मास होता है, वो सब हमको आइडेंटिफाई करना है, तो हमको किसी ना किसी एक टेक्निक की जरूरत पड़ती है. So in simple words, the spectroscopy is used to identify the molecular structure or the mass of the substance and what are the various phenomena taking place in any compound, any molecule. So that details we can study with the help of a spectroscopy. If we talk about the development, so we can say from the 17th century, जो हमारा white light को जब हम prism में से pass करते थे, it get dispersed into the 7 colors. वो सभी हमारा spectroscopy का एक basic, we can say that was the beginning to identify the spectrum and all. So but until the 1945, किसी भी मॉलिक्यूल का जब हमको स्ट्रक्चर फाइंड आउट करना था, तो बेसिक क्या होता था हमारा, वी जस्ट सी द मॉलिकुलर फॉर्मूला एंड द केमिकल रिएक्शंस टू आइडेंटिफाई द मॉलिकुलर स्ट्रक्चर. एंड in the very beginning the credit goes to our Sir Newton and the Fraunhofer to develop about the spectroscopy. So we can say that there are a lot of advantages in to identify any molecule with the help of a spectroscopy, and the organic chemistry has been revolutionized in the last 50 years by the use of our various spectroscopic methods. So students, let us just have a look on what are the various advantages of the spectroscopic methods. That they are very easy and fast, मतलब बहुत easily हम उनको कर सकते हैं, and they are give the result in a very less time. They give the more information about the molecular structure and very small amount of the sample is needed. Means अगर हमारा एक बार स्पेक्ट्रम हमने ले भी लिया है, then the sample can be restored. There will be no wastage of the sample. To study the spectroscopy easily, I have prepared a flow chart for you all. So you just point wise आप उसको देख सकते हैं. सबसे पहले we must know the definition, then what are the electromagnetic radiations, then its dual nature, that is the wave as well as the particle nature. In the wave nature, we will study the details of all the characteristics like wavelength, frequency, velocity, energy, wave number and the amplitude of the wave. And the particle nature, in short, I described our blackbody radiation and the photoelectric effect. Then what is electromagnetic spectrum and its range. Then what are the types of spectra, emission spectrum and the absorption spectrum. And the emission spectrums are also classified into three categories, that is our line spectrum, band spectrum, continuous spectrum. Similarly, absorption spectrum is also classified into 3 categories. I have explained the example of our sodium and the hydrogen spectrum here. Then the phenomena as a result of interaction with matter. So what the phenomena takes place, like our scattering, diffraction, refraction, then our different phenomena are described here. Then matter, according to the matter, we can divide the spectroscopy basically into 2 broad categories, that is the atomic spectroscopy and the molecular spectroscopy. It is very important for all the chemists because in nature molecules बहुत सारे number में exist करता है, so हमारा molecular spectroscopy is much more important than the atomic spectroscopy. So there is classification of the molecular spectroscopy and the different energy levels of the molecule or energy levels are described. And then what about the स्पेक्ट्रम हमको मिलता है, तो उसमें हमारा जो बैंड विड्थ एंड इंटेंसिटी ऑफ द स्पेक्ट्रल लाइंस हैव इट्स ओन इंपॉर्टेंस. एंड टू एक्सप्लेन द इंटेंसिटी ऑफ द स्पेक्ट्रल लाइंस, वी मस्ट नो द सिलेक्शन रूल्स allowed in the forbidden transitions. And in short, I explained about the instrumentation and the applications in the very short, because whenever you will study the different types of the spectroscopy like rotational, IR, UV, तो सभी का अलग इंस्ट्रूमेंटेशन होगा, सभी की अलग सिलेक्शन रूल्स होने हैं, देन सबकी एप्लीकेशंस भी अलग अलग होंगी. तो इस स्पेक्ट्रोस्कोपी वीडियो में मैंने कोशिश की है कि आप लोग को बेसिक कंसेप्ट का थोड़ा एक समझाएं, जिससे कि आप कोई भी स्पेक्ट्रोस्कोपी पढ़ेंगे तो आपके लिए इजी हो जाएगा. Students, we can define the spectroscopy as the branch of science which deals with the study of interaction of electromagnetic radiations with matter. Means here what we have to study? We have to study the interactions of electromagnetic radiations with matter. So what are electromagnetic radiations? Which type of the matter will be there? That details we have to study here. And we can also say that spectroscopy is the most powerful tool for studying the atomic and the molecular structure. So in this definition, interaction of electromagnetic radiation with matter, we have to study the details of electromagnetic radiations and what are the matter. Matter can either be your atom, either can be your molecule, either can be your ion. So the interactions of electromagnetic radiations with the matter can either cause the absorption of radiation or can cause the emission of the radiation. So we have, from the word itself, it is indicating that electromagnetic radiation. So it is made up of two parts, that is our electrical component and our magnetic component. So now, what are the electromagnetic radiations? So we can say that the electromagnetic radiations are the high energy radiations which travel in the space with the velocity of light, that is 3 into 10 to the power 8 meter per second or 3 into 10 to the power 10 centimeter per second. Then the electromagnetic radiations have the dual nature, that is the wave as well as the particle nature. So students, the wave nature is explained by the James Maxwell in 1870. And he was the first to give the comprehensive explanation about the interaction between the charged bodies and the behavior of electrical and the magnetic fields on a macroscopic level. When the electrically charged particle moves under the acceleration, the alternating electrical and the magnetic fields are produced and transmitted. These fields are transmitted in the form of a wave, and we can also see them as an electromagnetic wave or the electromagnetic radiations. As from the diagram it is clear that our electromagnetic wave, as the name itself, it is made up of two components, that is our electric component and the magnetic components. And these two components will oscillate perpendicular to each other. You can see here x, y, z, both are perpendicular to each other, and they will also perpendicular to the direction of the propagation of the radiations. So we can just say that our electromagnetic wave is an alternating electric and the associated magnetic force field in the space. So the students, what are our electromagnetic radiations? They are high energy radiations which travels in the space with the velocity of light, and they are made up of two components, that is the electric component and the magnetic component. And any radiations will have the dual nature, means wave nature as well as the particle nature, means some properties like our reflection, refraction, reinforcement and interference. All these phenomena are explained with the help of our wave nature. As the electromagnetic radiations do not need any medium for the transmissions, they can easily pass through the vacuum. So now let us see the important characteristics of the electromagnetic wave. The first important characteristics of the electromagnetic wave is our wavelength. Students, the name itself is length. So what we are talking about? Wave की length क्या होगी? So what we can say that wavelength is the distance between the two adjacent crusts or the two adjacent troughs. Adjacent means neighboring, nearest. दो adjacent crust और दो adjacent troughs के बीच का जो distance होता है उसको हम क्या बोलते हैं? किसी भी wave की wavelength. So we can see that this is our crust and these lower parts are our troughs. So the distance between the two adjacent crust and the two adjacent troughs is known as our wavelength, and the units of the wavelength are the units of the length. Length की units क्या होती है हमारी? मीटर, सेंटीमीटर, like that, so on. So similarly the units of the wavelengths are Armstrong, and the relations between the Armstrong, centimeter and the meter is written here. 1 Armstrong is equals to 10 to the power minus 8 centimeter, which is equals to 10 to the power minus 10 meter. The units are also our nanometers, millimeters, microns, millimicrons. Any units of the length we can use to define the wavelength. So characteristic is the frequency. Every wave is having the different frequency, and the symbol of the frequency is the nu. It is defined as the number of cycle in 1 second, means in how much seconds a wave completes its cycle from one point to the reaches to another point. Means if we consider this two part of a wave, so if we see these two waves, this first part is having more wavelength and the second part is having the less wavelength. So definitely to complete one cycle means crust and the trough makes the cycle of a wave. So the smaller wave will complete the cycle quickly. So it will have high frequency because the frequency is the number of cycles in 1 second. एक complete cycle में एक crust को cover करना है and एक trough को. And if we see the first part, so it will take more time to complete this cycle. Means if the length is more, our frequency will be less, and if the length is small, the frequency will be very very high. आप जल्दी जल्दी cycle को complete कर सकते हैं. So we can say that the frequency is the number of cycles in per second, and the units of the frequencies are hertz, and it is on the name of our HR hertz. And the bigger units are our megahertz, kilohertz, and they can also be written as the megacycles per second, kilocycles per seconds. 1 hertz is equals to 1 cycle per seconds, and kilohertz has the relation with the hertz is equals to 1 kilohertz is equals to 10 to the power 3 hertz, and 1 megahertz is equals to 10 to the power 6 hertz. As we have seen in the both the part of the wave motion that if our length is more, the frequency is less, and if length is small, the frequency is high. So there is a relation between the frequency and the wavelength, that it is inversely proportional to the wavelength. Frequency is inversely proportional to the wavelength. Greater the wavelength, smaller is the frequency, and it can also be written as nu is equals to C upon lambda, where C is the velocity of our electromagnetic radiations. Our next characteristics of the wave is the energy. Every wave is associated with a definite amount of the energy, and energy is directly proportional to the frequency. So we can just write, by removing this proportionality sign, we can take H. So the E equals to h nu over Planck's constant, and its value is 6.626 into 10 power minus 27 erg second. And we can also write this relation by putting the value of nu. Nu is equals to C upon lambda. So we will just write the E equals to h nu equals to h into C upon lambda. So this is the relation between our frequency and our energy, and we can also say that energy and the wavelength and the velocity, and where our nu is the frequency of and C is the velocity of an electromagnetic radiation. That value is 3 into 10 power 8 meter per second, and the lambda we have taken in the centimeter. So if we are the energy units can also be taken in the kilocalories per mole in place of the ergs. And now let us see our next important characteristics of the wave is our wave number. So what is the wave number? Wave number is the reciprocal of the wavelength, and we can just denote it as by the symbol nu bar. जैसे हमारा frequency का symbol होता है nu, and we are just making one bar, so it is the nu bar, and we can as it is the reciprocal of the wavelength. Means अगर हमारा wavelength is lambda, so we will write it as a 1 upon lambda, and the unit of lambda is if centimeter, so we can write the unit of wave number will be the centimeter inverse. And the mostly we are using the wave number in the explanation of IR spectroscopy. So you have seen the characteristics of our frequency, the wavelength, energy, wave number, and the next important characteristics of a wave is our velocity. So we can just say that velocity is the product of the wavelength and the frequency. And we can just write velocity with the symbol V is equals to lambda into the our frequency, product of the wavelength and the frequency. So lambda is the wavelength and nu is the frequency. So the unit of our velocity will be the centimeter per second or the meter per second. Students, as we all know that velocity is V is our vector quantity, so it will have both the magnitude and the directions. And for in the vacuum, regardless of the wavelength, all the electromagnetic radiations will travel at the same speed. That is the speed of the light. It is the 3 into 10 to the power 8 meter per second. And we will also use the velocity C here in the vacuum. That is a relation we already know that. That is the C is equals to our nu equals to C upon lambda, and we can also write it as in the form of C equals to nu into the wavelength. Wave is the amplitude. So every wave has its own amplitude, that is means the height of the crust or the depth of the spectra. So these are the various characteristics which are explained by the wave character. And now we can see that there are certain properties like photoelectric effect and the black body radiations which are not explained by our wave character. So Max Planck in 1900 given the quantum theory of the electromagnetic radiations, which explains the particle nature. Means we can say that the electromagnetic radiation, they consist of the stream of the energy packets, and these are called as the photons or the quanta, and every energy of the photon is proportional to the frequency of the radiation. That is, our E is directly proportional to the nu, where H is we have taken the proportionality sign. That is, if we write it like this, energy is directly proportional to the frequency. So by removing the proportionality sign, we can take a Planck's constant, that's H equals to H nu, and the value of H is equals to 6.626 into 10 to the power minus 34 joule second. So now we can say that these both the concept, this means we can say that the electromagnetic radiations have the dual nature, wave nature as well as particle. Any type of a spectroscopy, we should know about the electromagnetic radiations and what is electromagnetic spectrum. तो अभी हमने starting में बोला था what is the definition of a spectroscopy? It is the interaction of any electromagnetic radiation with matter. So matter can be your atom, ion or a molecule. So अभी हमने electromagnetic radiations की बात कर रहे हैं. Electromagnetic radiations क्या थे हमारे? They are high energy radiations which travels in the space with the velocity of light. Electromagnetic radiations are of different types. We can say that our gamma rays, our X-rays, ultraviolet visible region, infrared radiations, microwave radiations, radio wave, long radio waves. So there are many types of electromagnetic radiations in the space, and our visible region is small part of it. And we can also say that a white light is the simplest example of our electromagnetic radiation. Students, when all the different types of our electromagnetic radiations are arranged in the array, we get an electromagnetic spectrum. So here is a diagram for the electromagnetic spectrum. We can say that when all the this is the arrangement of all the electromagnetic radiations in order of their increasing wavelength or decreasing the frequencies is known as our electromagnetic spectrum. So here you can see that the wavelengths are presented on this side. Wavelengths are in the increasing order, and here we can see that the frequencies is in the increasing order. And as we can say that the wavelength is increasing towards our red end of the visible spectrum, and they are the least on the visible end of the spectrum. The visible region, as we all know, this is our Vivgyor, that is our violet, indigo, blue, green, yellow, orange and red. It extends from our 400 nanometers to 750 nanometers. And one more important thing that हम किसी भी एरिया को एकदम demarcate नहीं कर सकते यहाँ पर, है ना. When the violet finishes, indigo overlaps. When the indigo finishes, blue will come, है ना, so on. So we can say that the visible region is a small part of our electromagnetic spectrum here. The highest wavelength is of the red and the lowest wavelength is of the violet color. The radiations whose wavelengths are more than the red are known as our infrared radiations, and the radiations whose wavelength is less than the violet are known as our ultraviolet radiations. So all these radiations are arranged in increasing order of their wavelength, and we can say that the microwave, radio waves, long radio waves, all are having high our wavelength. So they are used in our transmission purpose, radio transmissions, like telecommunications and all. We can say that energy is directly proportional to the frequency. So the radiation who is having the more frequency are higher in energy. So the cosmic rays are highly energetic in comparing to our radio waves, and our radiations whose wavelength is more, like IR, microwaves, they are our less energetic in comparing to our ultraviolet X-rays radiation. So students, we can say that the source of radiations which we will use in the spectroscopy, the name is according to that. If we are using the source as IR infrared radiation, so the name will be infrared spectroscopy. If we are using the microwave radiation source, so it is our microwave spectroscopy. If we are using the ultraviolet radiations, then the name will be ultraviolet spectroscopy, and so on. So this is complete about the electromagnetic spectrum. So we can say that when all the electromagnetic radiations are arranged in the increasing order of their wavelength and the decreasing order of their frequency, this arrangement is known as electromagnetic spectrum. We can have a quick look on the regions of electromagnetic spectrum. The electromagnetic spectrum can be written as it is divided into the following regions. First is our gamma ray region. Its wavelength ranges is from 0.02 Armstrong to 1 Armstrong, and we can say that the atomic nuclei, gamma regions कहाँ से हमको मिलते हैं? आपने वैसे भी न्यूक्लियर केमिस्ट्री पढ़ी हुई है. We know that ना alpha, beta and gamma radiation. So the gamma radiation source is from the our atomic nuclei. Now let us talk about the principles of spectroscopy. So we can say that the most important principle is based upon the measurement of spectrum. Spectroscopy में हमको सबसे important क्या होता है? हम spectrum को measure करते हैं ना, किसी भी sample का हमको spectrum measure करना है. Then what is a spectrum? It is a graph or a plot of intensity of absorbed or the emitted radiation by the sample versus the frequency or the wavelength. Graph हम किस किस के बीच में प्लॉट करेंगे? इट आइदर द इंटेंसिटी ऑफ एब्जॉर्ब्ड और इमिटेड रेडिएशन ऑफ द सैंपल वर्सेस द फ्रीक्वेंसी ऑफ द वेव और द वेवलेंथ. Then what is a spectrometer? It is an instrument which is designed to measure the spectrum of a sample. What's a spectrometer? It is an instrument which is designed to measure the spectrum of the sample. There are various types of spectrometers, some single beam spectrometer, double beam spectrometer. When you will study the particular spectroscopy, then you can come to know that which type of spectrophotometer we are using. Then what phenomena takes place when the electromagnetic radiations interact with the matter. So either the absorption of radiation takes place, emission, then they can also do the transmission, then the radiations can be reflected, the diffraction, refraction, interference, scattering, polarization, the dispersions. All these phenomena are possible when the electromagnetic radiations interact with the matter. Now let us see the types of spectra. We can broadly classify the spectra into two categories, that is the absorption spectrum and the emission spectra. So we can see that when the source light is passed to any sample, the sample having the too many atoms molecules, they will absorb these radiations and it will jump from the ground state to the excited state, and these radiations of a particular wavelength or a frequency are absorbed by the molecule, and these radiations are absorbed, so the molecule jump from the excited ground state to the excited. When the atoms absorb the electromagnetic radiations, the absorption can only occur if the photon have the energy which is equals to the energy difference between the two energy levels, means delta equals to E2 minus E1. तो हमारा जो ये photon है इसमें कितनी energy होना चाहिए? It should be equals to the energy difference between the two energy levels. So it absorbs the radiation and it will jump from the ground state to the excited state. And how much radiations are absorbed here? We will study with the help of our spectrophotometer, and we will have a spectrum. This spectrum here is known as our absorption spectrum. We can see the simple instrumentation for this absorption spectrum. So this is the source which will give us a continuous supply of the radiations, electromagnetic radiations. This passes through our monochromator or the grating. Then these are absorbed by the sample, and then these absorbed radiations passes through the spectrometer. They will give us a spectrum, and the spectrum is plotted here between the intensity and the frequency. It will show us the variation of the intensity and the versus the frequency. And this spectrum is known as the absorption spectrum, as certain radiations are absorbed by the sample, and by the absorption they will jump from the ground state to the our excited state. We can say that the absorption spectrum can be classified into three categories, that is the continuous absorption spectrum, लाइन एब्जॉर्प्शन स्पेक्ट्रम एंड द बैंड एब्जॉर्प्शन स्पेक्ट्रम. तो स्टूडेंट ये हमारा डिपेंड करता है कि हमने सोर्स क्या लिया है, सैंपल कौन सा है हमारा. सैंपल इफ इट इज अवर एटम means like sodium, तो हमको line spectrum मिलेगा. If it is our molecule, then we will have the band spectrum, and if we are taking the mixture of the gases or anything, then our continuous absorption spectrum is obtained. Here it is the demonstration of a line spectrum. Means अगर हम देखते हैं कि हमारा source white light source है and the absorption is done by the sample, so if the dark lines are obtained here, means क्या show कर रहे हैं dark line हमको कि this wavelength of the radiations is absorbed by the sample. As we already know that our 400 nanometer to our 750 or 800 nanometer is the range for our visible region. So we can see the dark lines in our Wavegor spectrum, means what they are showing that this black lines shows that these radiations are absorbed by the sample, and these are the characteristic of a particular sample. So we can see the example for the continuous and the line and the band spectrum. we can say that the continuous absorption spectra, the best example is the source is our sunlight or the stars. Means जब हम sunlight का या फिर हमारा जो stars का radiations है उनका अगर हम spectrum लेते हैं then we will get a continuous absorption spectrum. वहां पर जो हमारा spectrum रहेगा there will be overlapping of the means we cannot separate the regions. कहाँ पर हमारा red finish हो रहा है, कहाँ पर हमारा orange start हो रहा है. Means आपने rainbow देखा है ना, we cannot identify them. So that type of spectrums are our continuous absorption spectrum. Then the line absorption spectrum, the best example is our sodium vapors. When this spectrum of sodium vapors is taken, it shows the two dark lines in the yellow region. That is our region of our 590 nanometer to 600 we can say ना. Yellow region में हमको two dark lines मिली थी सोडियम के लिए. So these are the means identification. We can say that the हमारा स्पेक्ट्रम जो रहता है दे आर द फिंगरप्रिंट ऑफ द पर्टिकुलर एटम और द मॉलिक्यूल्स. मीन्स अगर हमको ये दो लाइंस मिल रही हैं येलो रीजन्स में तो डेफिनेटली वी कैन आइडेंटिफाई द सैंपल दैट इट हैज अ सोडियम. सो वी कैन सी दैट द बैंड स्पेक्ट्रम वेन एवर वी आर टॉकिंग about our organic or the inorganic molecules. This is one example of the band spectrum and this is from the IR spectroscopy. Here you can see the spectrum of our pentanon 2. In the NMR spectrum, you can see the spectrum of our 112 trichloroethane. The band will be like this. This is the ultraviolet spectrum of our lycopene. We know now lycopene is present in our tomatoes, so the color is red because of this pigment only. So this is a UV spectrum. Means you can see the different types of the bands will be present in the different spectroscopy for the different molecules. So now let us talk about the emission spectrum. So for the emission spectrum, we are taking the substance और हम इस substance को क्या करते हैं, या तो इलेक्ट्रिकली एक्साइट करवाते हैं या फिर हम इसको हीट कर देते हैं. मतलब जैसे हमने जला दिया वो substance तो it will act as a source itself ना. So this is the sample is excited thermally or electrically and then these are radiations. जब excite हो जाएगा वो then it will come back to the ground state. Means कोई भी हमारा इसमें atom molecules रहेगा after the excitation they will jump from the excited state to the ground state, and when they will come back to the ground state they will again emit certain radiations, and when these radiations are studied with the help of our spectrometer we will have a spectrum, and this spectrum is known as our emission spectrum. The main difference between the absorption spectrum and emission spectrum is that in absorption spectrum हम क्या कर रहे थे, वहां पे जो radiations absorb कर रहा था हमारा सैंपल उसको हम स्टडी कर रहे थे तो हमें absorption spectrum मिल रहा था. जबकि emission spectrum में क्या होता है स्टूडेंट्स, जो हमारा सैंपल होगा it will get excited thermally or electrically and when it come back to the ground state we will study which type of the radiations it emits. That are studied with the help of our spectrometer, and the spectrum is known as emission spectrum. Again here the graph is plotted between the intensity and the frequency, and the emission spectrum we can say that it is in the form of the bright color lines which are separated by the dark space. कौन कौन सा radiations वो emit कर रहा है, it will be in the form of our bright colored line, either the yellow or orange. तो हमको मालूम है कि if अगर रेड लाइन आ रहा है तो रेड लाइन इज इन द अवर रेंज ऑफ अवर 700 to 800 रीजन है ना. तो इससे हम पता लगा सकते हैं कि दिस इज द कैरेक्टरिस्टिक ऑफ अवर पर्टिकुलर सैंपल हेयर. Now we can say that define the emission spectrum as when a substance is heated directly in a flame or heating it electrically, it get excited and some radiations are emitted when the substance return to its ground states. Means जब हमारा substance एक्साइटेड स्टेट से ग्राउंड स्टेट में आता है तो कुछ रेडिएशंस वो इमिट करता है, एंड देन व्हेन दिस रेडिएशंस आर पास थ्रू द प्रिज्म और द स्पेक्ट्रोमीटर अ स्पेक्ट्रम इज ऑब्टेन एंड दिस स्पेक्ट्रम इज नोन एज अवर इमिशन स्पेक्ट्रम. स्टूडेंट्स, लाइक अवर एब्जॉर्प्शन स्पेक्ट्रम, इमिशन स्पेक्ट्रम इज ऑल्सो ऑफ 3 टाइप्स, दैट इज अवर कंटिन्यूअस स्पेक्ट्रम, अवर बैंड स्पेक्ट्रम एंड द लाइन स्पेक्ट्रम. सो वी कैन से दैट The example of the continuous spectra is the incandescent solid, liquid or the gases, and the continuous spectra are in this manner, means there will be no separation in the particular color. Then we can say that band spectra, they consist of the bright bands with the discrete lines in each band, and they are the characteristics of the molecule. Means whenever we are taking the sample in the form of a molecules, we will have the band spectra. Just we have already seen the instrumentation, the band spectra will be observed in this form. Here we can see this is the emission spectra and some bands are there, and these are the characteristics of a particular molecule. Then we can say that The line spectra are which consist of the discrete bright lines and which are produced by the atoms or the gaseous and the vapors at the low pressure and the high temperature. So examples are the hydrogen spectrum and the hydrogen spectrum. And we can say that when we are taking a sample of our hydrogen gas, when we are exciting it at a low pressure, when electric discharge देते हैं तो हमारे जो atoms में electrons होते हैं they are excited, means हम बोल सकते हैं ना हमारा हाइड्रोजन का एटॉमिक नंबर 1 है, एक इलेक्ट्रॉन होता है, बट when we are taking a sample मतलब हम केवल एक एटम का तो स्पेक्ट्रम नहीं लेंगे ना, there will be many hydrogen atoms, so they will excite to the different level, and when they will come back from the excited level to the ground level, and when these radiations which are emitted by this hydrogen gas are studied in a spectroscope, a spectrometer, we will have this type of our spectrum. This is our emission spectrum, and we can say that there are many lines are obtained in the series, and the series are named as Lemon, Balmer, Paschal, and bracket and the fund. The spectrum produced by the sodium vapors. Students, when we are taking the sodium and we are just taking the emission spectrum of the sodium, we observe two lines, yellow lines in the region of 589 to 588 nanometer wavelength. As we already know that जब हमने सोडियम का एब्जॉर्प्शन स्पेक्ट्रम देखा था तब हमको डार्क ब्लैक बैंड्स, ब्लैक लाइंस दिख रही थी ना इसी रीजन में, लेकिन हमारा डिफरेंस क्या होता है इमिशन एंड एब्जॉर्प्शन स्पेक्ट्रम में? एब्जॉर्प्शन स्पेक्ट्रम में हमको डार्क लाइंस दिखेगा उसी वेवलेंथ पर, और इमिशन स्पेक्ट्रम में हमको ब्राइट कलर दिखेगा. मींस दिस इज द बेसिक डिफरेंस बिटवीन द आवर इमिशन एंड एब्जॉर्प्शन स्पेक्ट्रम. इमिशन स्पेक्ट्रम विल गिव यू द ब्राइट कलर्ड लाइन एट द सेम वेवलेंथ, एंड द एब्जॉर्प्शन स्पेक्ट्रम में वो लाइन्स हमारी एब्जॉर्ब हो जाती है, मतलब उस वेवलेंथ पर हमारा कोई भी हमको बैंड, मींस वी विल हैव द डार्क. वी कैन से दैट आवर एब्जॉर्प्शन स्पेक्ट्रा, हमारे जो रेडिएशंस एब्जॉर्ब होते हैं उसका एनालिसिस होता है, बिकॉज इस रेडिएशन एब्जॉर्ब करने के बाद मॉलिक्यूल हमारा ग्राउंड स्टेट से एक्साइटेड स्टेट में जाता है. दिस रेडिएशंस विच आर एब्जॉर्ब बाय द सैंपल, एंड जो लाइट ट्रांसमिट होती है उसको हम स्टडी करते हैं. जबकि इमिशन स्पेक्ट्रम में हमारा जो रेडिएशंस इमिट होते हैं आफ्टर द एब्जॉर्प्शन ऑफ द लाइट आर एनालाइज्ड विद द हेल्प ऑफ अवर स्पेक्ट्रोमीटर. सो नाउ जस्ट हैव अ लुक ऑन द डिफरेंसेस. व्हाट आर द मेन डिफरेंसेस इन एब्जॉर्प्शन? जो रेडिएशंस ट्रांसमिट होते हैं एब्जॉर्प्शन के बाद में उनको एनालाइज किया जाता है. इमिशन में जो रेडिएशंस इमिट होते हैं that are analyzed with the help of our spectrometer, and in the absorption spectrum we observe the dark lines, and in the emission हमको bright colored lines दिखाई देती हैं just like this, and in the absorption spectrum we observe the our dark lines in the spectrum. So these are the all about our absorption and emission spectrum. Students, we can say that most of the spectra are our absorption type spectra, and when we will talk about the atomic spectrum and the molecular spectrum, as we can say that the spectroscopy can be classified on the basis of the types of the matter into two categories, that is atomic and the molecular spectroscopy, because we know that the matter can either be in the atomic form or in the molecular form. तो हम बोल सकते हैं कि when the interaction of electromagnetic radiations takes place with the atom, that spectroscopy is known as our atomic spectroscopy, and the interaction of electromagnetic radiations when takes place with the molecule, that will be our molecular spectroscopy. So students, we can just see that what the phenomena will takes place when the interaction of electromagnetic radiations with the atom will takes. So if suppose we are talking about the atom, so we can say that the monoatomic substance are mostly in our gaseous state like our hydrogen and all. So when the electromagnetic radiations are interacted with the matter, if suppose the substance here in the gaseous state will absorb the radiation, and it will jump from the ground state to the excited state, and when the substance absorbs the radiation, the absorption spectrum will be produced. Means it will absorb certain radiation and some radiations will be transmitted. So this transmitted radiation will be studied in the spectrometer, and we will have a graph that is known as our absorption spectrum. And if suppose from when the substance will come back, means when the atom will come back from their higher excited state to the lower ground state, they will emit certain radiation, that is our emission spectrum. We can say that as the number of atoms बहुत कम exist होते हैं हमारे, तो atomic spectroscopy बहुत ज़्यादा study नहीं होती है, but the main important for the chemist, we can say that the molecular spectroscopy, means when the interaction of electromagnetic radiation with which takes place with the molecules, then for the either absorption will takes place our emission can take place, scattering can take place, dispersion, any phenomena can take place. So we can classify the molecular spectroscopy in the following categories. Our microwave spectroscopy, as already we had talked about the microwave radiations, they are having the high wavelength, and these radiations have less energy, so they will cause the rotation, means changes in the rotational energy level. So this spectroscopy can also be termed as our pure rotational spectroscopy. Similarly, infrared spectroscopy, so these radiations these radiations will cause the vibration of the changes in the vibrational energy level, so they are also termed as our vibrational spectroscopy. And Raman spectra is the result of a scattering, means these two above will talk about the absorption spectroscopy, and this can be the scattering, this will show the scattering phenomena. And this is our ultraviolet spectroscopy. As we discussed that the energy of ultraviolet light is very high, means they are having the less wavelength, they are high in energy, so generally the electronic transitions takes place here, and so this spectroscopy is also termed as our electronic spectroscopy. Then NMR is our nuclear magnetic resonance spectroscopy. This takes place in the radio frequency region. This is our nuclear quadrupole resonance spectra, and short NQR. Then this is our electron resonance spin resonance spectroscopy. We are also saying it as ESR spectroscopy. And our Mossberg spectroscopy, that is our nuclear gamma resonance fluorescence spectra. So these are the different types of the molecular spectroscopy, and we can just see that how the molecular spectrum will be formed. Friends, we can just discuss about the different types of the molecular energies and how the interactions of the electromagnetic radiations takes place with the matter. So if we see this molecule, if we see it has a certain rotational energy because it is doing some rotation. कोई भी molecule है, अगर वो rotation करेगा तो उसमें rotational energy होगी. And if we see this molecule is now vibrating, so it has some vibrational energy. And electronic energy means if it's jump from one electronic level to another electronic level, it needs some electronic transition energy. So we can say that interaction of electromagnetic radiations totally depends upon the energy of radiations. Then if we want this molecule rotate, तो हमें कौन सा radiation use करना पड़ेगा? If we want this molecule to vibrate, which source we need? And if we use our different type of radiation, which type of the phenomena are taking place? So all these can be clear from this spectrum here. As we can see that our different electromagnetic radiations are having different wavelength and the different energies. So we already discussed that the wavelength of the microwave is highest. So here this is a part of electromagnetic spectrum. So here the microwave is having the higher wavelength, though it will have the least energy, है ना. इसकी energy सबसे कम होगी. Then सबसे ज़्यादा energy किसकी होगी? हमारी ultraviolet radiation की. तो जब molecule के ऊपर हम हमारा microwave radiations डालेंगे तो क्या होगा? When the molecules are radiated with the microwave radiations, they can only undergo the rotation. Why? Because they have the least energy. Then if we use our infrared radiation, then the molecule can undergo the vibrations in the atoms. Then if we use our ultraviolet radiations, then molecule can go the electronic transitions, means electrons can jump from one ground state to the higher energy state. So we can say that if we use our ultraviolet visible region, then the electronic transitions takes place. If we use our infrared radiations, then molecular vibration can takes place. And if we use our microwave radiations, they will cause the rotation and changes in the rotational labels. So we can say that interaction of electromagnetic radiations with the matter totally depends upon the types of energy, which energy source we are using. Here in the three of the radiations, the highest energy is of ultraviolet visible region because their wavelength is the least, and then infrared radiations can cause the molecular vibration, and as the microwave radiations have the higher wavelength than comparing to IR and UV, so they can cause only the least energetic phenomena, that is the rotation. And we can also say that this interaction can cause the absorption of light emission और द स्कैटरिंग मीन्स 3 फिनोमेना होते हैं. अगर हम मॉलिक्यूल कोई भी हमारा इलेक्ट्रोमैग्नेटिक रेडिएशंस किसी भी मैटर के ऊपर फॉल हो रहा है, कौन कौन सा फिनोमेना हो सकता है? इट कैन गिव राइज टू आइदर एब्जॉर्प्शन, either emission or the scattering of that light. Now we can see these 3 interactions help us to study the detail of the matter, means हम matter का total analysis कर सकते हैं in a qualitative manner and the quantitative manner. So students, हमको स्पेक्ट्रोस्कोपी में ये बहुत अच्छे से क्लियर होना चाहिए कि हम कौन सा सोर्स यूज करेंगे and which type of the phenomena is going to takes place in the molecule. Means अगर हमारा molecule if the microwave radiations are the source, then the rotation हो सकता है because it's a least energy phenomena, and if we are using infrared then the vibration takes place. Vibration we will see in the detail, stretching and the our banding vibration, and if we uses our ultraviolet and the our UV visible region then they can cause the electronic transitions. I hope आपको interaction this topic अच्छे से समझना है to understand the further. Let us talk about the molecular spectra. When the light electromagnetic radiations fall on any molecule, these molecules absorb the light, means the sample will absorb the radiation and it will jump from the ground state to the higher energy state. Students, as we know that the molecular energy is made up of different types of energy like electronic energy, vibrational energy, rotational energy. So as we can talk, previously we have discussed that there are many types of energy, but according to the Born-Oppenheimer approximation, the energies can be the summation of main 3 electronic, vibrational and the rotational, as the translational energy is negligible. So the energy levels can comprised of the rotational, vibrational and electronic. We will talk just after. To explain the molecular spectra, let us talk about the different types of the energy of a molecule. As we can say that there are many types of the energies in a molecule like electronic energy, vibrational energy, rotational energy, and according to the Born-Oppenheimer approximation, the molecular energies are mainly the sum of these 3, and we are neglecting the translational energy here, and these energy levels are quantized. They have the fixed energies, and we can say that the different energy levels can be represented with the help of this diagram. These are our rotational energy level J1, J2, J3, and these many rotational level will make one vibrational level. This is our V1 is a ground vibrational level, and this is our excited vibrational level. We can say that V2 and so on, and this is our V3 again made up of many rotational level, and this is our V4 made up of many rotational level. So we can say that these black lines, these black horizontal lines comprises the rotational energy levels, and many rotational level will make one vibrational energy level. And students, this vibrational level means this is our V1, V2 will comprise to make one electronic energy level. This is our ground energy electronic level, and this is our excited state of the our electronic level. So when any radiations fall on the sample, तो हमको क्या होता है जब हम light fall करते हैं किसी भी sample के ऊपर, so if we can say that the molecule is jumping from E1 टू E2, एक्साइटेड हो रहा है मॉलिक्यूल हमारा, एब्जॉर्ब कर रहा है एनर्जी को, इट जम्प्स फ्रॉम अवर E1 टू E2. सो आप इस डायग्राम से देख सकते हैं ना, the transitions are taking place in E1 to E2, okay, but all these energy levels are getting changes, means the changes are taking place in the rotational energy also, then the vibrational energy levels are also getting excited. So simple words we can say that when any molecule is radiated with any radiations, the changes will take place according to which how much type of energy we have given to that particular sample or the molecule. So along with our rotational transitions, some vibrational transitions can also take place, and we can say that if 3 of the transitions are taking place, it can be termed as our electronic, vibrational and the rotational transitions. So in the simple words we can say that if we are using our microwave radiation as the source, then the only rotation will takes place, and we can term it as a pure rotational spectra. And if we are using our infrared radiations as a source, then we can say that because जब infrared radiations डालेंगे तो molecule में क्या होगा, वाइब्रेशंस होंगे एंड व्हेन द वाइब्रेशनल लेवल की हम बात करते हैं दे आर मेड अप ऑफ रोटेशनल लेवल. सो अलॉन्ग विद द वाइब्रेशनल लेवल चेंजेस द चेंजेस विल ऑल्सो टेक्स प्लेस इन द रोटेशनल लेवल. सो दैट्स वाई स्टूडेंट समटाइम्स आपने देखा होगा जो हमारे इंफ्रारेड स्पेक्ट्रोस्कोपी है उसको हम लोग वाइब्रेशनल रोटेशनल स्पेक्ट्रोस्कोपी भी बोलते हैं. एंड स्टूडेंट्स इफ वी आर यूजिंग द सोर्स एज अवर यूवी विजिबल देन द इलेक्ट्रॉनिक ट्रांजिशन विल टेक्स प्लेस. तो इलेक्ट्रॉनिक ट्रांजिशंस में क्या होगा, our rotation, vibration and our electronic transitions, 3 of them will take together, है ना. तो सबसे ज्यादा हमारे ब्रॉड स्पेक्ट्रम कौन से होंगे, हमारे यूवी स्पेक्ट्रम विल बी द ब्रॉड बिकॉज 3 phenomena are taking together. Rotational, vibrational as well as our changes in the electronic energy will takes place. Then that's why our UV spectrum will be broad. तो एक बेसिक चीज आपको समझ में आना चाहिए, जब माइक्रोवेव रेडिएशन सोर्स है तो हमारा केवल रोटेशनल एनर्जी लेवल्स में ही चेंजेस आएंगे. मीन्स द मॉलिक्यूल विल जम्प फ्रॉम वन रोटेशनल लेवल टू अनदर रोटेशनल लेवल. बट व्हेन वी आर यूजिंग अवर इंफ्रारेड रेडिएशन सोर्स द मॉलिक्यूल चेंजेस विल टेक्स प्लेस इन द वाइब्रेशनल लेवल में चेंजेस तो होगा, V1 से V2 जाएगा, बट द रोटेशनल लेवल विल ऑल्सो चेंजेस. बट इफ वी आर यूजिंग अवर यूवी विजिबल रेडिएशन एज ए सोर्स द अवर चेंजेस विल टेक्स प्लेस इन द रोटेशन, in the vibrational as well as the electronic energy level. So these transition can also be termed as our electronic vibrational rotational transitions. Now we can see how the molecular spectrum is observed. So when light is passed through a sample, what happens here, this molecule will absorb the light and the changes will takes place. इधर हमने वही बात करी है, the molecule will jump from the ground energy state to the excited energy state, means the changes are taking place in the electronic level in the ground energy state. And students just आपको मैंने बताया कि the changes will takes place in the rotational, vibrational as well as the electronic level. So how much energy how much wavelength are absorbed, that will be studied with the help of our spectrophotometer. Means when the electromagnetic radiations are fallen on this sample, it will jump from the ground energy state to the excited energy state and it will absorb certain frequency of radiation which will be equals to the delta E. Means that is the difference between our excited energy state and the ground energy state. And how much radiations are absorbed by this sample, the wavelength will be measured with the help of our spectrometer, and we can plot the changes in the absorption against the wavelength, and we can get a absorption band in our spectrum, and this tells us about the molecular structure of the sample. I hope आपको ये समझ में आया होगा. जब molecule के ऊपर radiations fall होते हैं, it will absorb certain amount of radiations. The molecule will jump from the ground energy state to the higher energy state. अब ये डिपेंड करेगा हम कौन सा लाइट सोर्स यूज कर रहे हैं. इफ वी आर यूजिंग द यूवी रेडिएशंस एज अ सोर्स, द ट्रांजिशन विल टेक्स प्लेस इन द 3 of the level, and so we can termed our UV spectroscopy as our electronic, vibrational and the rotational spectroscopy. Commonly we are just saying UV as our electronic spectroscopy only, and these how much wavelength is absorbed by this molecule is studied by the spectrophotometer, and then we can plot a graph against the absorption and the wavelength, and when we can get a spectrum of a particular molecule, and then we can study the details of the molecular structure with the help of our molecular spectrum. It is a characteristic of a particular molecule. The molecule, first thing we wish to know is how sharp is the and intense is the spectral line. In other words, we can say that the width and the intensity of the spectral lines are very important quantities for any branch of spectroscopy. So here we can say that this is a simple spectrum and UV spectrum. Here we can say the 2 peaks are visible, means हमको 2 बैंड दिखाई दे रहे हैं. These are broad bands because generally ultraviolet visible spectrum हमारे broad band ही देते हैं, because along with the changes in the rotational energy level, the changes takes place in the vibrational as well as the electronic levels. So we can see that the spectrum is plotted between the absorbance and the wavelength, and here the 2 broad peaks are at our 200 nanometer wavelength and the 600 nanometer wavelength. So just I told the broad bandwidth is very important for any spectrum. So here we can say that in any spectrum either you will have the sharp spectral lines or you can have the width, means हमको broad band type के spectrum मिल सकते हैं. And these two, our bandwidth is affected by the two factors, that is the collision broadening and the Doppler broadening. Next we can say that how the intensity of the spectral lines affects the spectrum. So the intensity of the spectral lines depends upon the two factors, that is our Boltzmann population and the transition probability between the two different energy levels. So as we already know that there are different types of the energy levels, like our rotational energy level, translational energy level, electronic energy levels, vibrational, and so on. So there are transition probability of the energy level, means there will be certain selection rule which will determine that which type of the transition is possible or what is the probability of different types of the transitions. So we can say that the transitions are governed by the certain selection rules, and these selection rules are the backbone of our spectroscopy, and these are explained by the quantum theory. Means the selection rules for every spectroscopy will be different. For example, for the rotational spectroscopy, the selection rule is our delta J is equals to plus minus 1, where J is our rotational quantum number. So we can say that when the transition takes place in the rotational energy level, plus 1 करके ही आपको ऊपर जाना है, means एक एक स्टेप करके ही जाना है, and you have to come back also by the -1 means आप ऐसा नहीं कर सकते कि आप दो लेवल एक साथ जंप कर रहे हो. अगर if you follow the selection rules, such type of the selection rules are termed as our allowed transitions, and the transitions which will not obey the selection rule, they are termed as our forbidden transition. Means if we will see that for the pure vibrational spectroscopy, that is our infrared spectroscopy, the selection rule is our delta equals to plus minus 1, means the vibrations will takes place from one level to second, means 0 से 1 पे जाएगा, 1 से 2 पे जाएगा, and come back also from our 1 to 0 or 2 to 1, मतलब gap होना चाहिए 1 का. So this, if the transitions obey the selection rules, they are allowed transitions, and the transitions which do not obey the selection rules are our forbidden transitions. The important basic part of the spectroscopy is about the instrumentation. Every spectroscopy have the different instrumentation setup, and we can also say that in the common things I will just tell you about any instrumentation is every spectroscopy will have its type of the source which they are using, then monochromator, then the sample cell and the sampling कैसे करना है. हर स्पेक्ट्रोस्कोपी में डिफरेंट रहेगा, देन विच डिटेक्टर दे आर यूजिंग, देन द स्पेक्ट्रम एनालाइजर, मीन्स दिस आर द पार्ट्स ऑफ द स्पेक्ट्रम इंस्ट्रूमेंटेशन. एंड वी कैन से दैट नाउ इट इज मेनी डिफरेंट टेक्निक्स आर बीइंग डिस्कवर्ड, और हमारा डबल बीम स्पेक्ट्रोफोटोमीटर या सिंगल बीम स्पेक्ट्रोफोटोमीटर्स आर यूज्ड. एंड जस्ट वी कैन से दैट द इंस्ट्रूमेंट which records the variation in intensity of radiation is known as our spectrometer. Means every spectroscopy there will be the different types of the spectrophotometers are used nowadays, and the most important part of our spectroscopy is the application. Why nowadays so much use of spectroscopy is increasing, and the different types of spectroscopies are also being discovered. So we can say that the main applications I have just written here. आप जब भी कोई भी spectroscopy पढ़ेंगे उसकी different applications ही होना है. तो common applications I have written here. It is basically used to determine the structure of the molecules. It can be either your organic molecule, inorganic molecule. It can be your complex. Then we can determine the mass of any compound with the help of our spectroscopy. Means mass spectroscopy, a different branch. Then we can also analyze the सॉइल ऑफ द डिफरेंट प्लैनेट्स. जैसे अभी हम देख रहे हैं ना, मार्स पे जा रहे हैं, वहां का सॉइल सैंपल लेकर आते हैं, उसमें कौन कौन से एलिमेंट प्रेजेंट हैं, क्या उसमें वाटर है कि नहीं है. ऑल दिस एनालिसिस इज बीइंग डन विद द हेल्प ऑफ अवर स्पेक्ट्रोस्कोपी. देन इंटरनल स्ट्रक्चर ऑफ अवर सैंपल. जनरली हम एक्सरे स्पेक्ट्रोफोटोमीटर की अगर आपने बात करी होगी, एक्सरे स्पेक्ट्रोमीटर, तो उसमें हम वी कैन डिटरमाइन द इंटरनल स्ट्रक्चर ऑफ एनी पर्टिकुलर सॉलिड्स ऑफ द क्रिस्टल्स. देन वी कैन डिटरमाइन द सिस ट्रांस आइसोमेरिज्म. देन द आइसोटोपिक स्टडीज ऑल्सो कैन बी डन विद द हेल्प ऑफ अवर स्पेक्ट्रोस्कोपी. सो दिस आर द सिंपल एप्लीकेशन आई हैव रिटन. जब आप IR पढ़ेंगे तो उसके एप्लीकेशन अलग होते हैं. UV spectroscopy का डिटेल पढ़ेंगे, it will have a vast application. So I can say that this is I have just tried to give you the basics of spectroscopy, जिससे कि आप कोई भी spectroscopy अगर पढ़ते हैं तो आपको काफी help मिल जाती है. So this is sufficient. Thanks for watching, and if you like my video, please share and subscribe my channel. Thank you.